All right, let's do some more Commander Keen reverse engineering. Let's see where we left off. We had a crash whilst exploring the graphical data or extracting the graphical data. We had a crash after extracting a couple sprites. Let's see. Let me get the sprites output on disk here. So we have our pictures were extracted correctly, as well as the masked pictures. Yes, those worked. The sprites, we had only a couple, like 338, but then it crashed, and it does seem, I don't know if this one is correct. Yeah, this looks incorrect though. Yeah, definitely not correct. So this one is correct. 316, 17. These guys as well. And 334 is incorrect. So this looks like the little guy. Like this guy here. So 334 is the first one that's incorrect. That is weird. Let's dump our information here. So we know it starts at 334. Correct targets here. In save game. Okay, let's see the output here. Don't know if that's big enough. All right, so 334. So apparently it starts from here. Yeah, the length is 3456. That is quite a bit too much, I think. I wonder why it does that, because these, unless it is the, well, I was going to say if it's the big guy. Oh, but we do have 285 is also a big one, 2560. That's 286. Oh yeah, that is the big guy. Yeah, that's the one I was thinking of. So this size would be bigger than even this one, which doesn't seem plausible to me. That's weird. Let's add the sprite count to our start thing here. Do we have a... Yeah, it's going to be this one. I can dump the sprite table as well, so we can see what that contains, because I might be reading that wrong. That was in EGA head, I believe. Yeah, chunk count, and can I? No, I want to do the... No, is it not in EGA head? No, it's not in EGA head, I guess. No, it's not in EGA head. It's in... Was it in EGA graph? Yeah, dump sprites. Yeah, it's dump sprites. Okay, in EGA graph, we have a dump sprites, and we have EGA graph here. But of course, I can't dump that yet, because in the constructor of EGA graph, it's extracting the sprites already, and it crashes in that. So let's not do that then. Yeah, so this function runs before I can dump the sprite table. I mean, it's going to be the same thing as we see here, of course, but still, I don't think I want to do that. I want to... Oh yeah, it's this one we have to ignore here, and then we can dump the sprites in main. Let's do that first. And then we can at least see the sprite table here. Oh, it stops at 3, 4, 5. Yeah. Okay, that makes sense, I think, now, because 3, 4, 5, I might be going too far, simply 3, 4, 5. Oh, no. So which one was the wrong one? Yeah, 334 is the first one that's incorrect, right? So 333 is 16 by 15. That's this one. This is a width of 2 times 8, of course. That's 16 by 15. That is exactly correct. And then the next one is 16 by 11. So 2 times 8 times 11. Oops. So 334 is 16 by 11. So the size is extracted correctly, but the graphical data is incorrect. It says that like these last 11 sprites don't work. Don't know why, but at least they exist. So it should go to 345, I guess. All right, let's do that again. This time by extracting the sprites again. So 333, yeah, 16 by 11, 16 by 16. Yeah, so those sizes are correct, but the data length is completely incorrect for this size of image. It should be 150 or something. And I think it says, yeah, so the size is, this size is 128. So I'm assuming that it is actually 128, just like these guys. Then the question is 334. Remember, we still had the chunk size thing here. This function is from Keen 6, and maybe that's the reason. However, I don't think we're in these numbers here. We should be in this range. So 1b4, what is 1b4? It's 436. So it's definitely in this range, right? It should be doing this. That would imply that the size we see there, which is 3456, is simply incorrect in the file. I guess what we can do is find this function in the executable, and then we can see if this is different, or if there's something that's like whether this is a hard-coded length for these two, because yeah, these guys are correct seemingly. Although if we look at the actual sprites decoded 336 is still incorrect, right? I mean, these two guys might have messed that up though. Let's find this in the executable. So I'm gonna have to launch Ghidra here. Okay, this is Keen 6. I have to add it. Games DOS Keen 5 1.4, the extracted version. Okay. I'm gonna name that Keen 5 P 1.4 unpacked. And we're gonna have to analyze this, of course. So it's gonna take a moment to analyze this. So that we can let that do its thing, because first of all, we need to find the address where this this Huffman decoding algorithm is touched. And I think we did look at that last time. So if you look at Keen 5 in a hex editor, Let me make that bigger. References. Okay, so the thing for finding the Huffman binary tree or the dictionary in the executable, I have to go look at the wiki again. There was a way by looking at the last 3 or 4 bytes. I don't know by heart. Right, so if we look at the dict here, so we can, it's possible to locate it by looking for the string FD01 and 4 zeros. Okay. And then we had to just determine which one it was because there's multiple. So FD01 and 4 zeros. Let's start from the start here. So this is the first one. And then we have here the next one. So we have 2. Now we just have to find this in running memory so we can put a watch point on that thing here. So I need to start the debugger here. Oh, let me scale that up because that's too small. No, this is in ROM. It's already here. I have a scale factor hard-coded here, which I should make a setting, which I haven't done yet. I'm in the constructor here. I can't remember where I put that. Oh, in the render function, I guess. Well, across font scale, I think. Font scale, maybe. Yeah, it's this one. So let's put this on 2.5 and recompile the debugger here. Right, is that big enough? Yeah, I think it is. All right, so we can close this back to EJ graph. Okay. So we're connected to Keen here. Now we can find this memory in RAM or this string in RAM, and it's going to be the same thing, I'm assuming, but we can compare with the hex editor, of course. Because the get chunk function is going to be called all the time, so this dictionary should be called multiple times too. We are going to get the MCB for Keen, which is the big one here, I'm assuming. Yeah, A13, and then we're going to find FD01 and 4 zeros. Oh yeah, this wasn't found, right? That's not good. Which is weird though, because it should be in here. Unless it's in this small one. It can't be in this small segment here. No, that's not possible. It should be in this big one though. Oh, did I type? No. So we do have FD01s. Okay, let's look it up in Ghidra. This one has finished. If we search here for our memory. Oh yeah, I have to invert that. So FD01 and zeros, we find 2, that's correct. So this is the first one. Actually, let's make that an array because it's 1024 bytes, right? So I think it's, well, it's going to start, let's do the calculation because I don't know. So this is the last byte. So I'm assuming this minus 1024. So 39424 is the address of that last byte, or the byte after. 39424 in hex minus 1024 is 400 hex, I think. 39024. It's this one. Yeah, it's this one after these full values. Yeah, C900. Yeah, that's the first one. So it's this one is the start here. Wait, let me just start with this one. So FCFD01 F0. So this is the second one. I'm going to start with this one. Data. Create array. This is an array of 1024 elements. Right. That should be the next one. And then let's find this one in memory. I'm assuming this is the one we're going to actually use. So can we add a label here? This is Huffman-Dict. Huffman-Dict 2, I guess, because there's one before this one. Right, so I wanted the address here, 6345F84 408A is the base, which is a different base. So we have to calculate, I guess, the physical address and then convert that. And it's an offset of 1000 hex, so it's 308A, I guess. It's strange that I can't find these values, though. They should be perfectly in here. So let's 9600, 93009D. Okay, this one he finds an end. So this would be the thing, right? The second yeah, this is this one, the second Huffman table. And for a size, so let's select the entire thing here, 39424 plus 1024. So plus is 39824. 39824. Yeah, it's going to be up until here. Yeah, so this is the table. And this should be straight in that memory, though. So 69. This is weird. This is a different table. Is this the same start of this table? C9D5. Oh, does it mangle the data here? I think I read something about that. Oh, that's that would make things a bit harder. Although it's not really an issue, because I still think this is the Huffman table. We still have the address, and it still should access this data, though. So it doesn't really matter if this data is not the exact same, because it's not the same, right? I see different stuff here. We have the ZYK here, the backslash QVJJ. Yeah, I mean, up until here is correct. Then we have CHG. Oh, no, it might be the correct thing. And then 1, 2, yeah. I don't know, it seems to start to differ like a bit further down. I don't know why that is the case, but we do have an address here. which I can put a breakpoint on, although I did not put my contextual menu on this pane, so I have to create a symbol for it, which is not a big deal. Let's go back to VS Code here and add a symbol for the Huffman table. Keen 5. Right, so we are at base 3813. At address, 1 second. Okay, we are at address 6924. And this is the Huffman table. And let's make that just U16. Yeah, I mean, it's 4 bytes, I guess, but that doesn't really matter. Let's make it a U8 and that's completely irrelevant. Then let's reload the symbols here. So we have our Huffman table. The 96 byte was the first byte. Yeah, that should be the first byte. Yeah, because if this is the previous one, we don't see the FD01 and 4 zeros either here. So for some reason that changed. They changed that. I don't know why. In Keen 6 it was identical. Well, it was identical to what I extracted. Yeah, so in Keen 6 there was an EGA dict file next to the executable, but what I didn't check was whether the EGA dict file was the exact same as what was in the executable. I verified in RAM, of course, but I didn't check in if it was the same in executable, because it could be that this is the actual correct one, and that I do a manipulation on the one inside the executable when it's copied to RAM or whatever. I don't know. But let's add a breakpoint here, a read breakpoint. Well, at 8-bit, let's put them all 8, 16, and 32, because I don't know which one, how they are going to read that, of course. And now hope that it triggers, because if it doesn't trigger, and of course it doesn't, because I don't see anything appear here. Maybe if I start a new, yeah, of course, it does. So it's reading a 16-bit value, and the addresses are wrong. I mean, the physicals are the same, but yeah, the calculation of the segment is a bit wrong. That's fine. We have a physical address. That seems quite high, though. Is that? So that could be, I don't know. Let's see if we can find this. I'm going to have to convert this. 1 second here. So 3E8A5 and 4. Okay, yeah, that does make sense. So 3E8A5 is a segment and offset is 4. That would be one of the things here that's possible. One of the segment offset addresses. Of course, I don't know. Like I think it references 3813. Let's see if we can pause here. Let's see if we can find the DS. 38AD appears to be the DS, the data segment offset. And in 38AD, that would come down to 5F 288D5F84. And the question is now, does that exist here? If you go look at the stuff here, so that would be in 288D, because we have a difference of 1,000. 288D. No, that jumps too much. I don't know how to jump to like physical addresses within in Ghidra, so that makes it a bit more difficult. So it jumps from 27 to 29, right? 29, 29, 29. Where's the thing here? Yeah, it jumps from 27AB to 29. And of course, we don't see a cross-reference here. That data isn't being requested, at least Ghidra doesn't see it. That's not a big deal. We can go to, if we jump our code, I think it just C to 388D5F84. We can there's an exchange thing here that is a bit weird. I don't know if that's the correct address. Let me double check the calculation for the physical address here. So what I said was 38AD times or shift left 4 times plus 5F84 is 3EA54. And what did we have? Of course, it's behind the thing. I don't remember the breakpoint result anymore. It's behind the interface here. I can't see that. Yeah, I have to check that. I have to check that because otherwise, yeah. Okay, that's what, that is the same. 3EA54 is the same calculation. So that is indeed the physical address or the breakpoint that. Oh wait, now it says. Why did it give me a different number just now? That's so weird. Oh, was I looking at the output of the debugger? Yeah, of course. I should have looked here. This is the one we need. 1C2134D. Okay, I was looking at the wrong thing. That makes sense. So I'm assuming it's going to be plus 1,000 and so 2CT21. 2C21. Yeah, the fact that it gave the wrong address was a bug on the debugger side, not on the DOSBox side. Of course, this was also not going to be found. It looks like because 2C doesn't exist. I'm assuming the address or the offset is still 1,000 different, and 0C21 doesn't exist either, I think. Or does it? No, it started at 1,000, of course. And it's not, maybe the offset is 0 now. I can always look up the hex code, the binary code, of course, that we can find it if this doesn't work. No, it's just from B to C as well. So let's remember this address here, and let's look that up in the DOSBox debugger. So let's start the game again. And now we will, let's go in a game, and then we will break, and then we will look up this address here. All right, this looks better. So these are our instructions in the code overview here, where we are accessing the Huffman table. So now let's look that up in our in Ghidra. So we search for our instructions here. I think we can do instruction patterns, and then we enter the bytes manually. I'm going to take these bytes here, right? So the 36AB17. I don't think I have to flip them. 36AB17 DOE1, and of course input mode is hex. 720A 730D. Let's see if we can find that. So this move, shift left, a conditional jump, and okay, so that should be found, which it is. And I think we found it here. Yes. So this function, yes, very good. So I immediately recognize it. If you watch the YouTube video on Keen 6, we already know that. I mean, I recognize this function because it looks the same as in Keen 6. We have these guys here, and we have these guys here. This is the going left and going right in the Huffman table, in the Huffman tree. And it has, again, the same two sections based on the addressing mode. So this is the exact same. So this function is the Huffman decode function. Okay. And then I'm assuming param 5. So the size, the maximum or the decoded size in Keen 6 was parameter 5. We can double check that here. Yeah, it's the exact same thing. So we have our exit condition for this first loop here. So we have a do while loop, and the exit condition is param 3 doesn't equal PCVAR3. PCVAR3 is going to be an end sentinel thing, which we calculate at the front. So PCVAR3 is param 3 plus param 5. So param 3 would be the start of the array, and param 5 is then the length, like you do a pointer arithmetic. And then param 3 is incremented one by one, right? So we jump byte by byte until we reach what the end pointer, like the end pointer is in PCVAR3. So param 5 is indeed the length, or the decoded length, which is what we need, right? Because that's what we are after. And now, again, if we compare to Keen 6, all we have to do is look at the references. Who calls this function? Who calls this Huffman decode function? And we see, again, 6 functions. The 3 are the same, and then 3 different ones, right? It's going to be the last one, but let's look at the other ones. Yeah, exactly the same. This one has a hard-coded Huffman decode function with a fixed size of hex 174. So that's not what we want. It does this 3 times. Oops. It does this 3 times, 174, 174, and 1854 hex. So that's not our function. And then the other 2 are, or the next 2 are better, but still are not the one we're looking for. Local E, it does some calculation based on whatever. But if you look at the last one, yeah, we have the exact same thing here. This is the code we are after. This is the get chunk function, exactly the same as in Keen 6. So this is the get chunk function. Why is that the case? Because we have an incoming parameter, which is the chunk index, and we have an outgoing parameter where we write the chunk data in. And the reason why this is the chunk index is because we check this in every if clause here. And depending on this chunk index, we set local 6 here to different values, right? And this local 6 is the 5th parameter that gets fed into the Huffman decode function. So we know the 5th parameter of the Huffman decode function is the size, the decompressed size of the thing. And this gets set depending on the incoming chunk ID, the chunk index. So we did find this function. That's very good. Now we're going to compare this with what we have for Keen 6, because the code I still have in the save game editor here is of course depending on keen 6, which is incorrect because we're handling keen 5 at the moment. Right, so you see something similar here, right? This is my comparable function. This here, yeah, I already see different values here, which is very good. Okay, so the same thing as keen 6. The first if clause is if it's below this value or between these two values. Right, so this is if it's lower than 130 and greater than 1331, then it looks for the decompressed size inside the data itself. Otherwise, it's hard coded. And 1C0 is going to be close to our problem here. 1C0. Oh no, that's 448. That sucks. So, well, because the problem was that our sprites. Wait, is this sprite index or chunk index? Right. What chunk index are we at? I don't think I dumped that. So sprite is sprite index, not chunk index. Right. We need the chunk index as well. Then it might make sense. So sprite. So this is. So the sprite index starts counting from 0 at the start of the sprites, of course. So the chunk index is going to be higher. So let's dump the chunk index as well. Let's compile the save game thing here. We might be close to 4.4 or whatever it was. And now let's run the save game thing, which is going to crash. But we are at chunk 441, and the one where it started to go wrong was 334, right? And if we look in the code now, so now we see the chunk is around 440, right? The chunk index is around 440. And if we go look in Ghidra now, we see that 1C0, which was 448. Ah, damn, so we're not there yet. So the thing, the moment these hard-coded sizes kick in, is after our problem here. It's like 7 after 448, and we're at 441. This sucks because that means that this isn't the cause of our problem here. That sucks. I mean, in any case, I'm going to copy the logic here, this logic, because this is specifically for keen 6. I'm going to just put that in a switch statement, I guess. Right, so let me make some space here, because we're going to have to look at Ghidra as well. Yeah, let me just copy this guy, these two values. I think I have a version here. Do I have a version in my EGA graph? I do not. So we need a keen version passed in the constructor here, because I need to do several things depending on which version we're in. I would like to keep all this data separate in a JSON file though, but I haven't done that yet. So if you go look at the keen executable here, we have different versions, right? So yeah, let's add that to our thing here. Can we just add the executable? And now we have access to those things that we defined there. So we are adding our executable version, which we are going to store in our thing, in our class here. I'm not going to initialize that because it's in the constructor. Let's add it here, and then we're going to add this here, and version is version. All right. And now we have a way of switching here on the version. We're going to do all of these, 1.4 and 1.5. It's going to be these guys. And then Keen 5 is something else. 1.4, I'm going to assume it's going to be the same for 1.4 and 1.5. Wait, do I not have that? Oh no, I only defined 1.4. Okay. I still have to look at the other versions of Keen 5, but I haven't downloaded those yet. Okay, so we have the same thing, basically, just different values. So we have, I'm looking here at the values 1C0 and 1331. And that is the code that looks in for the decompressed size in the data itself, which is this piece of code here. And then for 1C1, if it's less than 1C1, it's the 80. If it's less than 1C2, it's 5AO. That's the same thing. AFE becomes 7AA. 7AA is hex 80. Same thing. And then, okay, the same bug, I guess, as in Keen 6. We have dead code here as well. I don't know why that's the case, though. Like there's two duplicate if statements here. So the second one can never be executed. I don't know why that is the case, but so 1332 is A0. Yeah, and then the else is 280. So that is very similar as Keen 6, just a couple of different, because there's a different amount of sprites and tiles and whatever, so that does make sense. But it's not going to solve our problem. That sucks. Oh yeah, and we have to change in our main, we have to give the version now. Do we already? Yes, we do have the version. So we get the version here as well. I should link those to the executable so I don't have to like pass this in all the constructors, but fine. It's still going to crash though. That's the issue now. So let's try. Oh, we did not crash. That is weird. Yeah, we have 345 sprites and we extracted them all. So my calculation was incorrect and we apparently needed those extra offsets. Yeah, okay, so we do have 345 sprites. Let's see if the last couple ones are correct now. So we started at 333. That's our little guy here. This is correct. Then 4. Oh yeah, that's the rotated one. This one was corrupted already. Then we have the upside down one. I don't know why they're upside down. And then we have a cloud. Yeah. These weren't decoding correctly. We have another cloud. Cloud. 342. We have a couple left. Those are when the thing breaks, right? When the little guy breaks in pieces. 344 is a platform, and 345 is the final one, another platform. That's it. Yes, very good. So now we did extract all the sprites. I'm not going to dump the sprite table anymore. Very good. So that bug is fixed. Now let's extract more because I commented out a lot of stuff here because it crashed in the sprites. Right, so let's do the 8x8 tiles. These aren't that important because they are a single chunk. Let's start with the unmasked ones. And let's see if they extract correctly. It doesn't crash, at least. So let's look at the output here. So the sprites folder is complete. Now we have tiles 8x8. And we do have quite a few. Let's browse through them. Just a cyan square. I mean, yeah, so these are little numbers, and it does look correctly decoded, right? Let's take another one at random here. So these 8x8 tiles are just borders and corners of like dialogues and whatever. So these aren't super important. These don't make up the level data itself. So these are just edges and stuff, and little things in the user interface, not in the game itself. That little arrow. Okay. Now let's add the unmasked tiles. These might decompile or decode incorrectly, but we're not going to be worried about that. I think for Keen 6 they also weren't correct, but that's fine. Let me disable this output here in the sprites. We don't need that anymore. Okay, so now we have the unmasked or the masked 8x8 tiles. Yeah, so these are incorrect, but irrelevant. I don't know why these aren't decoding correctly, but we don't need those. The important ones are the next ones, which is the 16x16 tiles. And I hope that these decompress correctly, because we need those to make up the levels. Okay, so, oh, that's not good. This plane count shift should only happen once, and we do crash. Crap, that's not good. So 1963, that means... So what is the plane count shift? They put all the 16x16 tiles in one, not one chunk, but because they're all separate chunks, but one consecutive set of chunks, right? And we have to determine when it changes from 4 to 5 planes. In other words, when it changes from unmasked tiles to masked tiles. In other words, if there's a 5th plane, an alpha plane present, which we can detect, of course, but this should only happen once, and it happens at seemingly the correct position, which is at 1963, meaning there are 1512 unmasked tiles, and the rest would be masked tiles. But then it starts happening again at the end here, and this is totally incorrect. I mean, which would imply that they would have some masked or unmasked tiles after the masked tiles, and that would be not good, unless my sizing here is wrong, because it's crashing too as well here, right? So that means we might be going over. How did we determine the amount of tiles? Oh, wait. This is hard-coded. Yeah, no. So this might be my problem. I have Keen 6 hard-coded values in here. Yes, my end stop here is while chunk index is smaller than 5550, which is a Keen 6 number. That's not good. Okay, so that makes sense. I don't know why I kept that hard-coded, because you should be able to determine how many there are in total, right? So if we look here, so we did all these guys, and now we're doing the 16x16 masked and unmasked tiles. So how do we know how many there are, though? So 16 totally occasionally absent, that's not applicable here. There's several thousand, both come in masked and unmasked kinds. Each tile is an individual chunk. These chunks, so this is the problem, right? These chunks do not have a D-word specifying their decompressed size. That's why we looked up in Ghidra what their decompressed size is. So we have a picture table, a mask picture table, sprite table. These all contain amounts for us to determine how many there are. So I guess we're going to have to guess. Well, I mean, see until where it goes, and then that will be it. I think this might simply be a hard-coded number inside the executable that they added, but we don't know, or we can't determine from the EGA graph file. So what we can do, so I'm assuming that it stops here at around 4913, so one less than this one. I think that would be the end. Yeah, so let's look at the 16 by 16 tiles and see what happens at 4914. So we have our tiles here. Okay, that's a black tile, a little star. So they are being decoded correctly, at least. Those are the backgrounds for the map. Okay, so these all seem correct. There's like thousands of them though, so it's going to be hard. We'll make an atlas in a moment so we can look at them all at once. Yeah, this looks like from the space station, maybe. Don't know what this is. Oh yeah, so here we switch over from unmasked to masked. I mean, they do look correct though. Yeah, this looks like text. Yeah, this is keen, right? And now we go to mask. This is the foreground tiles. Yeah, this is a Shikari bomb, I guess. Something like that. I don't know where that is. I haven't seen this in the game though. I don't know where that is supposed to be. Okay, so this does seem to be correct. Okay, let's look at the end here, and we can see where our problems start. And it's go, yeah, okay. So I'm assuming this is going to be the last masked tile. These do look, I mean, they don't look like much, but they do look correct though, at least. Yeah, this looks like a border that's in the game. And then this one is going to be, yeah, this one is garbage. You can immediately tell that this one is garbage. So the last chunk is indeed 4463. Or chunk 4913. 4913. Okay, yeah. So this is the 4914 would be the first one that gives us problems. So that means that it's not 5550, but let's make a variable here that says last chunk. Well, should I do last or amount? I should do an amount, right? I need to know at 4913 what the amount is. So I need to know. Let's have that calculated. 4913. Yeah, which would be the last one. Let's print out the total count, I guess. Which we have in, so we have a tile index. Do we reset the tile index? We don't reset the tile index, I think. So tile index start at 0, and we increment tile index regardless of whether it's a masked or unmasked, because this is the difference between masked and unmasked. Okay, so let's just dump the tile index then. I mean, I have this number, of course. This is in the, this would be this one here, 4913. So chunk index 4913. I know this is a bit small, but 4913 is tile index 4463. Okay, so it's 4463. I'm assuming that's going to be the number. So, and this is going to be last. Yeah, I did this wrong yeah. So I'm looping until the chunk index is less than 55550 or 5550, meaning that in 6 the last chunk of the 16 by 16 tiles is 5949, and I do reserve this amount of space in my vectors to store them. But of course, it only starts at 450 or like around 450 because the previous chunks are before. So I'm reserving too much money, too much space for these things, but that doesn't really matter. So I just need the last chunk index. And then we're going to switch on version. And we're going to do the same thing as here. And we're going to do first chunk index equals 550. And then for this one, which is key 5, we put that at, I mean, it's not, yeah, it's 1. I'm going to change this to smaller or equals. Well, let's change that to 5549 so I can use this number. That makes more sense, right? If it's the last. So the last one would be then, let's look in the files here. 4913 would be the last, 4913. And then we break and we reserve this. This is too much, but it doesn't. I mean, I could subtract 450 or whatever it is, but that doesn't matter. That doesn't matter at all, actually. And that number doesn't occur, or 5550 doesn't occur anymore. Okay, so now we should not see this anymore. We should stop at where we should stop and don't crash at all. Yeah, 1 plane shift and the total mass tiles are 2952. Okay. And then if we go look, I mean, I should delete my files because this is not going to go away, of course. So I'm removing the folder here and run the thing again. And then if I look in my tiles folder, the last tile is something very transparent, but that looked to be correct. Yeah, this is some map thing. I don't know what. All right. So that is all we need to extract from EGA graph. Because now we can make the atlas, which we can then use in the save game editor, of course, right? So let's see, how did I do the atlas? Completely forgot. Oh, I have a dump sprites thing. No, we're already doing that. I'm rendering. Yeah, I guess I could do the game maps. That's going to be the same, right? Yeah, let's start with this one, with dumping the texture atlas PNG. Let's see if that works. I don't think there's hard-coded values in that. Tiles per 100. Yeah, it just looks at the size, right? Yeah, it looks at all the tiles. Okay. So if we do this, then we should get a PNG containing the entire atlas of the thing. Let's see if we have that. We do. 135 kilobytes. So these are all the tiles that are in the game. And we see the shift from masked or unmasked to masked. I mean, we should see that. Oh yeah, so these are all solid, right? And these are, so the bottom part has transparency and the top part doesn't. See, there's lots of gaps, which is fine. That means that those chunks are simply not used. Yeah, so, oh yeah, you see the helmet here. I don't know if you can see that. Where my mouse is. The helmet here is the start of the masked tiles, because these guys have all transparency from that point onwards. But it does look like we are decoding correctly though. Like, I think there's fewer sprites than Keen 6. Let's look at Keen 6, because I have the atlas for Keen 6 as well, of course. And I can look that up here. Scene 6 Tile Atlas. Oh, those are the sprites. Yeah, oh, it's about, yeah, it's not that much different. Yeah. Looks right, it looks about the same, I guess. Yeah, it's about the same. I don't know why Ubuntu switches between, or the picture viewer switches between a white background and a gray background for the transparency. Not sure why it does that. Okay, so we have our tile atlas now. We need this for later. This is the tile editor code itself. Let's see if we can decode the game maps file the same way. I don't know if we need any specific data, right? So this is going to be the same. Oh yeah, no, we need map head, right. So this is map head for Keen 6. We need to make this versioned. Yeah. Okay, let's find map head in the executable. And if we will look at the wiki again, we can see that there's a trick to finding this. It's the map head is here, right? So we have a magic word signaling RLEW compression, which is ABCD or CDAB in the executable, and then 100 pointers to the start of the level data, which is what we're after, and then the tile data. So if you look in the hex editor, we simply have to look for CDAB. And let's start at the start here. And we have these two matches here. That's big enough. So what we see after CDAB should be like 100 pointers to the start of the level data, but we know that there's only like 14, 17 levels in the game. So there should be like 80 zeros, as in null pointers, and we don't see that here, right? We don't see any data that resembles like 100 or 80 zeros, nor for the next one. Here, this one neither. But then if we look at the next one here, we do see that. So we have our CDAB, we have our 14 or 17 levels, however there are, and then so this is about 100 pointers, and then we have the tile info data. So this is this structure here. So we found our data. I just need to add this to the executable now, and then we can decode the game maps file as well, because we need these pointers. Of course, we need to know where in the game maps file our data is, our specific level is. So I'm going to copy paste this here, and we're going to make that. I mean, this is not the best way to do this, but I'm just going to copy this and then do a switch statement. On the version, right? So Keen 5, and this is Keen 5, and this is Keen 5 level count, and then I'm going to. So how many do we have in Keen 6? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 levels. And now we have to count here. So it's going to be these guys. Right, these are 32-bit numbers. I'm assuming, yeah, they were 32-bit, right? Because, yeah, of course, they have to be larger than 65 kilobytes, of course. I was confused by the one here, but yeah, these are 32-bit values. Can I copy paste these, or do I have to type this over? Let's see how it comes. I mean, they're in the wrong order anyway, so I think I'm going to have to. Of course, it doesn't copy at all. yeah, this doesn't copy. That's going to be manual labor here, which is going to take a moment, but it should be fine. Should I ask AI to do this for me? Let's see if it can do that. Well, I can't copy paste the thing. Why does it not copy? Why does it not? Is it because of the null character? Yeah, that's weird. I mean, that's fine. Doesn't take that long. So 1AF1 to F3E. I might make a mistake here though. 4352. 5404. I'm switching the bytes, of course, because of endianness. 6BD1. If there's a mistake, then we'll immediately see that because it will either crash or give the wrong data. 7C72. 92C7. 9D60. AFOC. BDA9. D47A. And that's it. And then E800. FE76. 1DC3 and 1FDE. Okay, so those are 4 fewer levels. I can verify that, of course. So how many do we have? 1, 2, 3, 4, 6, 7, 15 levels. I said 15, right? Let's look in the thing here. Do we have Toastbox open? Yes, we should connect. No symbols loaded. Why not? Okay, let's crash. Why don't we? Oh, is it? Oh, yeah. I'm right. I'm in debug mode, right? I'm blocking here. Yes, of course. That's why it's why it didn't work. Let's restart. Okay, please don't crash. And let's start the debugger again. Right, so now we have our gain state. I did drag the levels. So we go from finish level 1 to 13, which makes for 14 levels, right? Which is what we had here. I already forgot. 15. We have 15, but the score level is also on there, I think. Doesn't matter. We'll just decode them and see what comes out. We're going to have to add a version here as well. And was it key executable? Why does this? No, it was executable version. Let's add a member here. All right, so we have access to the version now, which means we have to pass this to the EGA, the game maps thing here. So let's load this one in. The namespace is just keen, and we need CK5. Why are we complaining? Oh yeah, of course, because we need a version as well. I think I need to copy the thing next to it though. I don't think I have the game maps file. Yeah, okay. So we're in games DOS keen 5 game maps over here. So we have to have it next to the executable because I'm just putting the path like this. And then let's just render the first one to start. Let's render level 1. I don't know what these false and trues were. Render background and foreground. We do want all of those. So I'm going to set both to true. And now we need to switch on the version before we dump. Dump plane where this did get used. Well, we can't compile because it's, yeah, we renamed the variable here, right? So what is this type? Stud array. So let's see how we're going to do that. Can we do a pointer to this? And then we need the same switching. And then map head is the address of this one. Can we do that? Yeah, this is going to be, can we do this? Because it's a const expr thing. Yeah, that does work. And then we have to switch on in this. And this one is complaining about not doing all the possible options here. Keen 5 needs to be defined. Oops, 5, 1.4, and then map head equals ms map head keen 5. Okay, so now we're switching on the correct map heads. And the size is also going to be an issue, I think. Why are you not? Requires a suitable begin function was not found. Why did? Oh yeah, of course we have to dereference that. Yeah, the level count was also a variable we changed. Where is that? Issue. Oh, this needs to be predicated on the version as well. So let's put that in a function then. And then switch on the same thing. Where did I switch? We need this switch. Here. And then we return, I don't remember what we returned. What did we return? MS level, oh, just a level count, exactly as is, okay. 6 level count and 5 level count. Why are we complaining here? Undefined, that's nonsense. Why is this? I mean the correct thing. We have M version here though. Why is it not? What stupid thing am I doing here? Why are you complaining? Did I make a mistake here? Oh, it's a, right. Oh crap, it's a, but these are static too, no? Oh yeah, of course, yeah, I need to, yeah, and version is not static, of course. Crap. Not this then. Doesn't matter because it's a static. It can't know that because that's an instance variable. Right. Yeah, that one was static. You can't complain anymore. Okay, very good. Now we go back to main, and we're just rendering the first one. So this should work. Let's see if we can not crash. We do crash. Okay, so this crash means that we are requesting a tile that is not in our atlas, which sucks completely because oh, unless the switch here, yeah, the 2952 might be also a thing. This the transition between the unmasked and the masked tiles might also be a factor here. Yes, that actually might be the reason why it crashes. Let's look at the render function. I don't remember the number for Keen 6 by heart. Yeah, here, 237. Yeah, this one. I'm going to put this in a simple hard-coded value. This should be, like I said, all this version-specific data needs to be in a JSON file that gets loaded, because otherwise it's going to be like spread all over the code. That's not good. But yeah, this is just a simple testing. So I think that's the reason. So this is the start of the masked tiles, so we're rendering foreground here, and we're painting the plane starting from this offset and in Keen, which is for Keen 6, and for Keen 5 the number is different. I think that's why it's called. So the plane count shift happens at chunk 1963, and I think that's the number we need. Or unmasked tiles 1512 maybe. Yeah, I think it's 1512 that we need. Yeah, I think it's 1512 because the tile, it uses tile indexes, meaning we're starting from the start of the 16 by 16 tiles, not from 0. So it's not a chunk index, it's a tile index. Okay, so let's give those some values here too. So Keen 6, unmasked 16 by 16 tile count is this one. And then for 5, it's going to be this number, 1512. That is quite a bit of a difference though, but yeah. And then, so this is for 5. And now let's use that value again with the switch statement in our thing here. And we use this guy for 6. And then 5 is 5. All right, and now let's see if we crash again. We do not. Let's see if we have level 1 that looks like it's level 1. We've written the PNG now, right, with the level 1 here. Yes, this looks like level 1. So of course it doesn't have, I mean, I did put some spacing in between as well, but I didn't put, the sprites are not in there, of course. This is just the tiles, but a foreground and background tiles seem, I mean, this looks correct, right? This is the first level. Let's do all of the levels and then see if they all get decoded correctly. So we're dumping all of them, and the version is going to be this one. Okay, now we have all of the levels dumped. And let's look at the files. So now we have all the levels here. We already saw the first one, then we have level 2. Also looks correct. Level 3, very long one. Yeah, I don't see any issues. Level 4. 5 on another long one. Those are those, yeah, depending on the name. These are the tunnels or something, right? I think they use for that. But yeah, that looks correct. Level 6 with the fuses. Another tunnel. Level 8. Nine, another tunnel here. Level 10 with 4 fuses at the bottom. Level 11. This positioning might be off. Well, no, because it's tiles, right? No, it's the sprites that might be off. I know that the sprite position is correct. Thanks for the follow, Geekcasts. And then we have level 12. Oh yeah, this is the final level with Shikari mines at the top, and then the thing you have to destroy with the Shikari mines. Doggies. And do we have another level? Yeah, we have level 13. Oh yeah, that's the secret level, the Korath base, Korath 3 or something, with the fuse at the top. And then the long thing down. Yeah, that looks to be nice and correct. And that should be it. Oh, 14 is the score. Okay. So that would be the score level. And that's the texture atlas. Okay, so we did do that correctly. We need a sprite atlas as well. We did export all the sprites, but we need to put them in like a sort of sprite atlas. I don't know why it's missing his head there, but I'm guessing there's going to be a reason there. Right, so we need the sprite atlas. I think I have a script for that. But I think that's all we need for the save game executable here. Yeah, we have the game maps. What else can we do here? I don't think we can do anything more. Yeah, so that is fine. All we needed from this is the tile atlas, the texture atlas of the tiles here. Yeah, this is the important one. So now we switch over to the save game editor, which we can do. I mean, I have it open here, I guess, so we can close this one, right? We have these guys. Yeah, so this is the atlas for the sprites, which we need to create. This is for 6. We need to create one more for 5. And then we have our tile atlas. Let's start by copying this file in there. So we have this one. It's right here. So this becomes Team 5 tile atlas. Okay, and now we need to run a script here that that creates our sprite atlas. So we have a JSON file which we need for the website, which the thing is going to create for us. So we have helpers, right? Yeah, we have helpers here. So this is the pack sprites thing that we need to run. Oh yeah, I put that hard-coded. That's not good. So this is now in Keen. Five. Okay, so this should be, that's the output, right? And then the input there is now correct. It looks for the sprite folder. Yeah, okay. So let's run it again. No sprites found in save game, but that should be save game sprites now because I changed that indeed. Okay, so this is, yeah, these are what we need. And we should have our files here. Yes, Keen 5 Sprite Atlas. That looks nice. We don't need all the sprites in the save game editor, of course. We have our atlas here. So we have width and height in our JSON, and we have the 346 is the count, which we can determine from this as well, but that should be fine. All right, so that's good. What do we need now? Let's get the websites up. And go to the save game editor. All right. Let's see what we need. So this is going to have to be changed to mention 5 and 6. And this is index. I don't need index nor this. Close the blog. Keen save game editor. Yeah, so this is 5 and 6 now. And it's in the header too. I mean, I'm going to change this to like just Keen. Once I have all of the keens done, then of course I don't have to specify all these separately, of course. All right. I'm going to have to make an example per keen version, of course, because that matters, and we need to change all this, of course, as well. I'm going to make a standard save game for us to test, so I don't always have to drag one on there. Let me position myself a bit elsewhere in the level, for which I'm going to cheat, of course. No, these guys can push me off. Let's make a clean save. So keen 5. Why is this empty? What the? Why are these folders empty? Oh, what is? Yeah, we have save game 0 and 1. I'm going to both delete these, so we make a why? Oh, is this a file selection thing? Okay, never mind. Right, I'm going to remove these, so we make version files. Because as we've seen in the blog post and the video, is that Keen just takes the file that exists and writes its data in the save game without truncating the end. So we can get leftovers if we don't do a version file. And I don't know what was the ion ventilation system. Yeah, that was the first level, right? So let's name it ion ventilation system. Okay, so we have our save game, our dummy test save game. We can close this, and this, and this. Now I think I've saved my dummy save game here somewhere as well, maybe with the images. Yeah, I did. However, I didn't name that. I didn't version that, so like let's name that. I might be checking on the fact that the file name is save game number.ck whatever. Oh no, it's ck. Oh, it has ck5 and ck6. Okay, that's fine. Right. They won't clobber. Okay, so I have that thing now too. We can use. Now, so we need to make an entire new block here for all the specific things here for Keen 5, right? Because this is specifically for Keen 6. We have our Vivas here, and we have the rope and grappling hook. That obviously doesn't exist in Keen 5. Why is it being weird? Oh, I did. Okay, sure. Never mind. But first, let's see if we can load the thing up and dump to the console the stuff that's in the file, right? So let's load example 5. Right, and the process file might need it might need to determine. We'll do the determination whether it's a 5 or 6 in the code itself. We're not going to do this on the JavaScript side. Let's just because we can determine based on the magic number in the file or the file version number, we can determine which version it is. Also, we know the extension is CK6 or CK5, but that's less reliable than looking at the thing itself, of course. So we're fetching and we're processing. So this is completely going to crash now because it's going to use Keen 6 stuff for parsing the file. Let's see what happens anyway. Yeah, it doesn't like that at all. Okay, I don't know if I can make the thing bigger here. I can. Yeah, okay, that's no. Okay, did I not make that correct here? Load example 5 and 6. Load example 5 and 6. Oh, I did switch the numbers, but why do we not? Okay, so that 5 does nothing. Okay, so it's silently failing. I did not do error handling for the failing of the of parsing the file. I should do that because it's not doing anything. But fine. So we process the file in drop zone. So the matching is already I mean my to-do is right here, like to-do complaint. So this should be 5 or 6, I guess. In the regex. Do we get it? Yeah, we get any further now. So entity list points to RAM address ABCD. That's also a very good thing to know because ABCD is the RLEW compression magic number. The reason why we're doing this is because our offset is wrong. So the game state in key 6 and 5 has a different length because we have different properties. I think as in key 6 we have the rope and grappling hook, which we don't have in key 5. So the space reserved for that doesn't exist in key 5. So we're reading the file simply wrong, which is not a big deal because we just have to adjust our thing here. And this doesn't happen on the JavaScript side. This happens on the WASM side, the mscriptum side. So let's go look in the code here. Where's my code? In save game, I guess. Let's see what we have here. That is, so there's also 6 specific hard-coded data, which we need to adjust. Right, see all these structs need to be versioned as well. The entity, not so much. The game entity appears to be the exact same between 5 and 6. I haven't checked 4 yet, so we can reuse this. But game state needs to be game state key 6. The file header is the same as well, I believe. I don't know about the title size. We do have to check the title size if that is indeed the case. I do have to quickly check that, although, wait, no, I can check that. Can I check that? No, I cannot. No, I have to count, just to be sure, right? Because we don't want to make a mistake here. Let's launch Keen again. And let's launch the debugger. No, I don't need a debugger. I need to save a file. Okay. New game. And we save. And then let's do the last slot. And then we do all else because, as I've explained, it limits the length of stuff you can put in the title here by how long the field is, not by how many characters is at first. So if we want to know the exact amount of characters, we take a short letter or a thin letter, and then it stops here, and then we can find out how long that information is. Let's look at that in the hex editor. So here are our L's, and if we see, we have these guys plus a null byte. Oh yeah, wait, no, I'm going to do something else because we're missing some data here. We're missing the map location before we enter a level. And if I do enter a level, we'll see some data over here, which gives us a better indication as to where the thing stops. So go back to the game and go back in the first level. And now this data gets written here. Once I save, we'll see that. We'll overwrite this one. Oh yeah, I need to reload. Yeah, so we now see these two guys. I don't know where is it. I think it's 1800 because it's a high number, right? Because it's in the thousands. Let's go look in the debugger anyway. So if we look at the game state, map X and Y position is 1800 and 5600. So if we go back to the text editor, this is 1800. So this is the game state, right about here. And then, so we have 2 null bytes after the thing, which is probably padding, right? Was there padding? Yeah, this is wrong. I should adjust this because there's, well, no. Yeah, no, there's 1 padding, yeah. So we have 33 characters in key 6 and 1 padding byte. And if you look here, we have, including the null byte, 1 padding byte, and this is the game state. So this should be 33 from here to here. This length is 21, so 2 times 16 is 32 plus 1 is 33. So the length is 21 bytes, hex 21, which is 33 in decimal. So that's exactly the same. We see our version here as well. which is important to know. I will add this here. This means keen 6. And now we have keen 5 1.4 equals 9C21. I don't know what the meaning of these numbers is, but this is a version number that implies which version of Keen created the save game file, and it doesn't allow you to open that version in a different version, or that file in a different version. I think I have that set somewhere too. Okay, we need to copy all this data. We don't know the entity type names yet, I don't think I've done all of those. The level dimensions we need as well, and then a couple of offsets, which is going to be the same. Well, no, not this one is going to be different. This is not necessary. We might have to just determine this from the size of the headers here. This game state is going to be an issue because I need the same struct with different parameters. I'll have to think about that. Okay, so this is completely the exact same for both games 6 and 5. This also is wrong in the sense that this can go away. This is just 25 levels instead of padding or unknowns around that. That should be the same thing. So it should work still by doing that. Yeah, this should still work with Keen 6. Yeah, it does. And then these guys should work too. Yeah, that seems correct. However, so my game state is something that I export into or embind, I guess. Yeah, so this is game state. This needs to be game state 6, right? Or game state Keen 6, because I do use that. I mean, the game has to be, or the save game editor has to be aware of which version we're currently in. So we're going to have to use it anyway. So we have to rename it anyway. Let's see if we can refactor that in the game or by in VS Code. I mean, so this one, yes, that one too. Yes, and then save game by dump function. Okay, yes. So now I'm binding the 6th version, but my JavaScript still needs to reference the correct thing here. Where did I put that again? Yeah, this all needs to change or be versioned, I guess. So, oh yeah, it comes in here, I guess. So GS as applied game state is called with GS being the game state. Yes, so it asks for it from the save game. This needs to be versioned as well then. This comes from save game. This has a function that returns it. Yeah, this is game state Keen 6 then. and in mBind as well. Okay, that should be good. And then mGameState needs to be, I mean, it's fine. I guess I can, I can just keep a game state for each version in memory. That's not that big. So now we have this, and now we need one for 5 as well. Let's first change this so it keeps working, right? So this still compiles, and now we need to request here game state key 6, I guess. And that should still be working then. No, that's not a function. Well, it might be. I mean, I did change that. Oh, no, I didn't change it here. All of it, I guess. Here, this one here. No, where's the function? Game state key 6 needs to be game state key 6 in the mBind. And then this should work. Still, it does not. It still doesn't know that this is a function. Game state, so SG game state key 6 is not a function, but it's right here, game state key 6. This might be the WASM file messing with me. We're in the save game class. We did recompile this. In 549, oh no, this is in the thing, right? Oh, game state key 6, the function itself is not found. Game state key 6, game state key 6. I mean, it does exist though. Let me download the WASM file. Sometimes that helps because it can be cached. So if you download this and then force reload, it might fix it. It doesn't. Oh no, it does. It did fix it. So that is the stupid thing with this web development stuff. Like it cached the WASM file. I recompiled it. I force reloaded, and it still didn't get it. But fine, I guess. Can't access properly checked. Apply game state. Where are we? Apply game state. So are we not in here then? Checked. They're telling me levels. Oh yes. This is the change I did from 17 to 25, right? I think that is the issue here. How did I define these in my thing here? Completed levels. So level, yeah, this is incorrect because this doesn't start at 0, right? It starts at 1. Crap. Yeah, it's indexing in the wrong level now because I changed it from 1 to 17, from 1 to 17 to 0 to 25 or to 24. Yes, it's probably the last one, the 17, that is missing. So I guess I have to manually. That should help. It doesn't. Can't access properly checked. So document is still. Well, I don't know why it stops here now. Why it doesn't go into the apply game state function? Let's look at that function again. Levels is indexed from 0 to levels length. Right. We should start from 1 and Yeah, we should start from level 1, right? Yeah, because level 0 is not. $18. Okay, so that is one too many now. Okay, so we do start at 1 now, but we need to, so GameState.levels function. Yeah, we're indexing into an array now, right? So from that should go to 17, no, not 18. Let's look in the function. This is in GameState, so no, I'm asking the size from GS levels, so GameState.levels. Where is levels? Get levels. This is in get levels. No, this is just levels. Oh, it's this one. Okay. So what do I do here from 0 to finish levels size? And finished levels. That's going to be the array I changed, I guess. Right. So this should go to 24 because I did change that. Yeah, finished levels size is now an array of 25 levels. Yeah, so this goes from 0 to 24, and it's setting all of them. So the thing I'm returning here is a 0-based array, obviously, where the levels should be indexed along their actual level ID, which means from 1 to 17, I guess. So why am I requesting 18 here? Unless my loop is wrong then. Oh yeah, but okay. I'm doing something stupid here. I don't know what it is. I'm starting here from 1 because we're not interested in level 0, because level 0 is never finished, right? That's the map. So we start from 1, and we have, let's say, 13 levels in this case, and levels.length. Oh yeah, no, this goes to 25. Right. Okay. Yeah. No. This should have been the level count that is actually in the game, not the array size, not this array size. This is actually fine. I'm just going to check if it exists. Let's do this. How do we check whether this is undefined again? Is it like this? EL is null. Okay. I always forget these things if you mix so many languages together. Let's look that up. It just checks it. Okay, just if element then, I guess. All right, so now, I mean, this should be fine. We have to retest that later, of course, but that's okay. So now we still can't do this, of course. Yes, that's the same issue. At least we solved the levels problem. Now, where were we? In our save game, we need a game state for Keen 5, which is slightly different. And we can look at our reverse engineered data for Keen 5, which is here. We are in Keen, we have this one here. I've called it map. I don't know, what was it called? Omega, what was it, the map name again? Omega Matic? Yeah, Omega Matic, right? So we start with these two. Oh no, not sacks. And then we have 25 levels. We have our 25 levels, and then we have score. Score extra ammo, and then Vivas is Vitolin in Keen 5. We have no sandwich, rope, pass card, rocket location. We have a key card though, whether you have the key card or not, which is a bool 16, which is a 16-bit value. And then we have an unknown, which I still haven't figured out. Okay, let's name it 2 because that's fine. And then we have fuses left. Those are the fuses you have to break in the game. The amount of fuses that are not broken, I guess. And then we have our red, yellow, blue, and green gem, our location, lives, the difficulty, and the pointer of the platform you're standing on. So that's the rest. I'm going to implement this function, but that shouldn't. I mean, I haven't done it for that one either, so that's fine. We're going to knob that out. So now we have at least game state Keen 5. Now we just have to use that to read in the data here instead of the 146. And how do we do that? We have to check that in on the JavaScript side, I believe. So we need to export that here as well. And we need to be able to request this. So we need this function in savegame as well. Let's store this in our class. We have a game state Keen 5 now as well. And oh yeah, so over here I have the level count hard-coded in the thing even, which I should have just exported, but fine. We seem to have from 1 to, that's 14 levels, right? Or 13 levels. Yeah, so it appears to be 13. And I don't know where we're going to use this exactly, but we just need to have a function that returns the game state Keen 5. So this one here, we need to implement. All right, so now we have access to both game states, which we can export here. That's fine. Now we need to export our game state as an mbind thing as well. So let's update this one. Let's put them in order. And then those were Omega Matic, right? Omega Matic X, oops, and Y. And then we had Score Extra, that was Vitamin. None of these guys. We had an keycard. We had an unknown. I'm going to export it, but we might figure out what that actually is before we release the save game editor. We have an unknown, and then we had already forgotten. So we have the keycard unknown. So Vitamin keycard unknown fuses left, and that's it. All right, so now we have, yes, this is the same. So now we export our game state for Keen 5. That compiles. Now the only thing we need to do is, well, first we have to parse the file correctly, and then we have to make sure that the JavaScript doesn't, is going to mess up these values here, because it's we need a different section here for Keen 5, right, with different IDs. So we're gonna have to rename all these IDs. I mean, I guess I can just conditionally hide these guys and change Vivas to Vitalin and stuff. That might be easier. That would only become a problem when we have two things with the same name in two different games that have a different meaning. But I don't think that will happen. If that happens, I guess, like if difficulty meant something different in Keen 6 than in Keen 5, I don't think that will happen. Let's look at the parsing first. So load data. So after the, over here, we're doing immediately after the file header, we do immediately game state Keen 6. We can perfectly look at the file header and determine which version it is by looking at the file version, the byte 5 and 6 or something, or 6 and 7. Yeah, let's do that, and then we need to keep track of which version we are in, though, because we're going to have to switch on these guys too, depending on which version it is. And I don't think I tracked this already, so that means that's something we set in load data, right? Because that determines what version we're actually loading. So I don't think I'm going to make a distinction between the specific versions of Keen within a game, as in 1.0, 1.4, and 1.5 for Keen 6, because those are apparently all the same. Unless we start encountering a difference between save game file formats between the multiple versions within one game, then we can adjust where necessary. But I'm just going to make a simple version enum and say is Keen 5 or Keen 6, right? And then we'll store the version. I have to initialize that. I mean, let's put it on none, because we start a thing without anything defined, right? So, and we only assign this in the load data function. So here we're going to determine what the version is. we're going to switch on mfile header dot version, which is that byte. And then we are going to have to look at all the values here. Yeah, these guys here are going to determine which version we apply. Oh, shouldn't have deleted that. And then we're going to have a default, and we'll have to complain that we can't parse the thing, because now we are checking the actual version number. It has to match one of our versions, one of our known versions, or we just can't parse the file. So we have to complain here and actually return, not break, right? We're returning from load data. We have to actually reset mdata and stuff. Right now we're in an uncertain state here if we encounter that, but it's fine. And then we just say version equals, or current version equals keen 5. Keen 5, and all the other ones are keen 6. Right? So now we know our version. We're going to leave this behind for a moment and assume that the file we're dropping is an actual save game file. And now we are going to switch on the version, right? Yeah. Keen 5, we do this, and then for 6 we do what is written there, and for 5 we do it in game state 5 and the size of 5, and then the current offset. Yeah, so this we don't need anymore. We're just going to do the offset by this calculation here. Let's make that a variable, plain offset, plain start offset. And we're going to set this to of course should be 5. So that's either the file header plus the struct of the game state 5. Yeah, that should be correct, right? Because we have packed our structs, so those should be fine. And then we can leave this behind, and we can just use plain start offset, and then we can, I don't think I'm using this anywhere else, so that is defined here, right? So we don't need this one. The magic is always at 0. The level will figure out, well, we can access the level easily, right? Like the level is, I think, the location thing in the game state. We'll just find it somewhere else. Yeah, so this one we can drop to, and then get bytes. Yeah, we don't need get byte anymore, I think. That's in compression Carmack that we don't need, and this, yeah, level index, yeah, that's the one we needed. This can just go. We need to switch on the version again as well, because this differs for, well, it shouldn't differ. Yeah, it does, because the level is after our rope and grappling hook and stuff, which depends on the version. In Keen 5, we just return the game state 5 dot location. I believe that's the thing, right? I believe that's the level index thing. Let's see where that function is used. I think that's what it is though. Level is level index. Oh yeah, because we're using the level size, the plane size, the plane sizes. Yes. So that is indeed the current level we are in. Yes. Okay. So that's correct. It's depending on the location variable in the game state. Yep, that's correct. What are we missing? Oh, yeah, okay, that's fine. We're not going to encounter that. Oh, version, okay. Probably in the other one too, I guess. Where are we here? That is just a NOP. Because, yeah, this return is already going to trap that, so this none is not going to occur. So now we need the level plane sizes. The level plane sizes is hard-coded in this. Oh, I did dump that. Okay. How did I get that information? I think I just dumped these out of convenience so I could use them in the level editor. Actually, if we decode all the levels in game maps, we should be able to dump these values too, right? So there should be some remnants of this function in my other project here in the ROM hacking thing. So if we look on game maps, there should be a thing to dump. Come on. So we don't have this hard-coded here. Data size, I think it's data size that we need, right? Dump plane, does dump plane give me information about that? No. Oh yeah, see, these are the sizes, I guess. Yeah, so we need the length of the planes. Yeah, it's these guys that we need. And I don't think I have something commented out in my thing here. Let's just use the dump plane thing. Where was I? Here, game maps dump. And it dumps all the level headers. Yeah, that's all of them, right? A vector of level headers, yes. So let's just do the dump function then, I guess. We don't need dump plane, right? We need. I guess it's these guys though. Why did I do that different? So the length of the plane is, should that not be the same number then? Maybe I did that to compare. Let's just call the dump function, then we know what the output of this is. We don't need to render them right now. Okay, let's see what the output of this is. Okay, it is indeed these numbers. So the length of plane 0 is the compressed length. Then I guess, was that the case? I guess it was. And then the . but isn't the data plane size the multiplication of level width and level height times the size of a 16-bit value, 2 bytes? Wouldn't that be the case? Oh yeah, so 42 bytes for 50, is that correct? Because then we don't need these values. So let's go to decimal here. We have 42 times 250 is 10,500 times 2 for 2 bytes per, oh, not divided by 2, 10,500 times 2 is 21,000. Yeah, so that is just a simple calculation of 2 bytes per tile. It's a 16-bit tile index. And then we have the level sizes, so we don't need this value. I don't understand why we would need this. Because the value we see here, for the last level, which is this one here, the 816. This is for the score thing, right? And it's the same here for the high scores, 24 times 17, 816, 816. So it is indeed these numbers. So I don't know why we need these numbers. We can just because we have the level dimensions here, right? So 62 times 90. Let's double check whether these numbers match. So it should be 62 times 90 times 2 would be this. Let's see if that tracks. So 62 times 90 times 2 is 11,160, and it's 11,160. So I don't need this. I don't think I need this. I can just, yeah. So let's see who complains if I don't have this, and then we'll just fix this function. Yeah, the plane length. So we have the level index. We just need to look up the sizes. So auto level width, level height equals, what's it called? This guy at level, which is the level index. And then the plane length is level width times level height times size of the 16-bit value. And that should do fine, right? Yeah, we don't need that information stored. Does this still work? Yeah, of course. Yeah, that still works. So that's not an issue. Let's remove that then. We're going to have to add these level dimensions though. And that's going to be typey work again, I guess. I mean, I can just, yeah, let me just print that out because I don't want to type over all that stuff. It's going to take me the same amount of time to program something than to type it out, but sure, I guess. So let's do it in the dump function. We're already printing stuff there. So I'm going to do a separate loop so it doesn't mix in with these guys. We need what exactly? How does it look? We need this, right? With a comma. How do we escape? Is it just double braces? Don't know if that's gonna work. Or is it backspaces? Not sure if that's gonna work. Otherwise, I'll have to escape it with backspace. I'm not sure. So we need we need M level, or we need the level header here, and then LH.level width and LH level height. Let's see if that works. If it's oh yeah, that did compile. Yes. And so 52.114, 58.88, 52.114, 58.88. Okay, so those numbers are correct. Now we can just copy paste this in our code here. This is key 5 level dimensions, and that should be it, right? Okay, I guess this is implied. All right. Now we have that information as well. So we have 13 levels, but level 0 doesn't come into play and the score doesn't come into play, but we do have the sizes, of course. That doesn't really matter. So we can index in this array, which is 0-based, with a level ID, which is also 0-based. Now, yeah, this one needs to be predicated on the version here. We're already switching here, so let's be clever and just, oh no, we can't, because, well, we'll have to move this one in there too then. Because we can't access the level index if we don't have the game state, right? So let's, this is a size T. So let's load the level here after parsing the game state. So level equals level index, but level index is simply this, right? And we're already switching there. Do we use level index elsewhere? Because otherwise I'm going to throw this function away now. Yeah, we do. Actually, no, I'm just going to simply not use the function, but go straight for the game state, this one location, right? That's what it basically is, right? We don't need to call the function. So we have level, and then we need these guys, right? And then we're going to do the plane length here as well. And we're going to define plane length above here. Okay. And this is 5, and that's 6. And that should work. Okay. Okay, 6 still works. 5 is not going to work, of course. It's probably going to be, when it does open up now. Our tile indexes are wrong, but this is because of the another thing we have to version on between 5 and 6, which is the start of the unmasked and the masked tiles. At least we're getting something here. And also I'm loading the wrong atlas, of course. I'm loading the 6th atlas. You can recognize stuff from Keen 6 here. It needs to be Keen 5, but that's fine. Let's see. So we were parsing, right? So we parsed our version. We determined which one it was, 5 or 6. We are loading our game state. Then we determine our plane start offset. Oh yeah, which is apparently correct because it decoded pretty much correctly, as in the decompression thing didn't complain. I have some unknown entity IDs, but that's because I am not I haven't given those a thing yet, right? So entity 9, it's complaining about entity 9, but I don't think that exists in Keen 6. We go look here, entities. Yeah, see, we have a blue glad is 8 and a Flix is 10. So it's trying to apply the IDs of Keen 5 onto Keen 6 now, because we haven't duplicated this yet. But that's for later. That's fine. So we are RLEW decompressing. We're adding game entities. Okay, so this should be, yeah, is unknown entity needs to be predicated on the current version, right? and this is key 5 entity names. I don't know if I've done those already, but this is allowed to be, like, if it doesn't exist in this map, then it will just say unknown entity. Let's look in the other one. I don't know if I've done it already. Let's look in the JSON file here. Entities, entity types. Yeah, no, only the camera and commander key. So I haven't looked at these guys yet, which we can do later. Meaning we're just going to copy this actually, and put it before here, and close that thing off. So we only have the camera, and there's no grappling hook, of course. It's a bit weird, so they're reusing IDs when you're on the map or when you're on the in the level. For some reason, that entity ID is reused, as far as I could tell. Okay, that's the thing with the none, I guess. Is unknown entity is true if it's none, which cannot happen. Version is not. Oh, it's a static. It's a static. Meaning we have to pass our version in here. I mean, can I just not make that not static then? And then entity name is the same thing. Let's also make that not static. That doesn't cost that much. If it is not an unknown entity, then we have to switch on the versions again, I guess. Who is complaining? Oh, this guy here. Yeah, this is not a class function anymore. Oh, I might be in trouble here because I'm calling this on the JavaScript side as well. Okay, let's fix this one first before we look at that. Okay, yeah, that is game entity dump is dump a. Is that a static function? Game entity. Yeah, that is a static function. Okay. I'm going to ignore this because this needs to be version. Well, can I just make this? No, because game entity is a struct, right? I'm trying to, yeah, this one has no idea which version we are in. Unless I just, no, I'm going to ignore this because we don't need to dump entities right now anyway. That's fine. We might run into the same problem in the JavaScript, right? Which is entity name stuff. So let's look. Yeah, so this calls the static thingy here. We do know the version in this thing as well, though. So we need to call it on save game, right? We can just do get save game, can we not? Yeah, because So render game entity, yeah, we have save game here. So we can just call it on save game, I guess, instead of calling the static version. Yeah, that should do it. Entity, yeah, so those are not, okay. The place where this gets called is when you click on an entity here. Yeah, and it still works. It shows the details of the entity. And then that appears to work. So that's not a big deal. And the name is coming through as well. I don't know if it's not a known entity, but yeah, the function does run though. Yeah, okay. So that's fine. What else do we have to do? We have the entity names. Yeah, the fall through we need to copy as well. This is the tile info data to know if we drop a thing here, to know where to stop, to know where we can fall through and where we cannot fall through. So we have to extract that as well. Let's look at the renderer now, because if we load this, so we have unknown entities, it's not complaining about these guys here for some reason. I don't know why it's not complaining about not finding. I guess it wouldn't do that, right? Yeah. So if you look at what happens when we load a file here, yeah, so apply game state is a function that applies all the game state to the thing. This needs to be versioned as well, because this can't use these locations. Actually, I should get these locations from the C++ side, though. I don't know why I'm putting this in the JavaScript side. Do I have this information? I do not have this here. I should get that from the C++ side and have a function for that, so I don't have to add that to the JavaScript. Let's make sure we can ask for the version of our current save game, so we can predicate on the version on the JavaScript side as well. So we have a version variable, but we don't have a. So we have our current version here, but we don't have a function to get the version, right? Oh, we do game version. Okay, I did implement that. Yeah, of course. So game version needs to be exported. Do we have game version here? Yes, we do. Okay, I apparently added that. I already forgot about that. So we can ask game version here. So game state, we need a save game, no. So we have to ask for save game. Yeah, this one here. Oh, wait. How is that implemented? Oh, yes, this used to be the get byte. Wait, no. Oh, I duplicated this function then. Yes, I did. So game version returns the version string, right? Yes. Okay. Commander key. So this needs to include all of this key. So this should be key 6. I think we should just set like this should go away, right? Yeah, let's just call that function and have that do the thing here. So this is right? And then we just set these guys. Is that a static function? No, it's not. Why are you complaining? Oh, it's a const function. Okay. Okay, so now we do this, and then we can just do game version. We call game version at the top, and this gets set correctly. Right, so our variable gets set here, and I mean it keeps getting set over and over every time we ask for game version, but who cares? That's not a big deal. And then we just set this to none. Yes, that's cleaned up. That means that, oh yeah, so yeah, this should be get version string game. This should be game version string because it does return a string, and we need a function that returns the actual version enum, I guess. And this goes away, and we move this higher up because we need this higher up. Because we need to change stuff here depending on the version, right? So should I just return a number 5 and 6 instead of unbinding the enum? I think that's easier, right? Just ignore the whole enum thing. I guess so. Well, let's see. Do I have other enums exported? I mean, I guess I have. So we can just copy paste. It's fine. Key SGE save game version, and then we have like this, and then we can make a function that gives us the version itself. And this returns current version. Okay, so now we have a function that returns the game version enum as well, and we export that into save game. Okay, and now we can use that here. E5 1.4 is the, am I doing this wrong here? Yeah, it's confused because this is a cache problem. Oh yeah, I didn't compile apparently because it was showing the old string version instead of the enum. Okay, this returns an object, but that is indeed that that enum, yeah, version keen 5. So it should be the same, I believe. I think we can compare. Is it just version? I think it's, yeah, it's just version that is available, right? Keen 5. And if it's 6, just do some test printing. 5 is keen 5. That's correct. And keen 6 is keen 6. Okay, so our enum is exported on the to the JavaScript side. So now we can use that. We say if it's 5, so the first core extra ammo vivas is for 6. So we're going to do something different for 5. So this is for 6. And now we're going to run into the problem that we don't have the correct fields in our editor thing, but that's fine. So Vitalin, actually the game state we get here, yeah, this is hardcoded to 6. This needs to be, yeah, this needs to be different too. Okay, but that's fine. Let's start here. So if it's 5, we ask for Vitalin and Vivas in 6. Then lives and difficulty. I have to look at the structs again because I don't know them by heart. So we have so Vivas in 6 and Vitalin, and then the keycard is right after, and the unknown is right after. We're not going to do the unknown in the interface, of course. So let's do the keycard in. Okay, and then the items in keen 6. So this one here. Oh, I didn't put those in order then, I guess. That doesn't really matter though. I can just move them in because the order doesn't matter, right? Yeah, the order doesn't matter. And then keycard is keycard. This needs to be a checked thing because that's a Boolean, whether you have the keycard or not, and Vitalin is an amount. So in 5, we check the Vitalin and the keycard, and in 6, we do the Vivas, the rope sandwich, and the rocket postcard and its location. And then the rest is the same, I think, right? So fuses left. Okay. I mean, the fuses left thing is a bit weird because you can't really change that value. If you change the value, then you can get stuck in the game. So that should be just an information thing, I guess. I should add some prefixes to these fields that are game specific, so I don't mix them up. Because now it's doable because there's only 2 games, Keen 5 and 6. But if I add some more games, then yeah, then that's going to be, that can get confusing, of course. So these guys do not exist. Let's add them quickly here, and then we'll do the hiding later. So in the second thing here, in the second column, we can add the Vitalin keycard and the things left, even though they are not used for, depending on which game you look at, right? So these should not be drop downs. So we're going to take Vivas as an example here. Actually, let's put it under Vivas. That should be fine. So Vitalin. Vitalin now exists, and what did we have? The uses left and keycard. Keycard is a checkbox. So the gems are an example of that. checkbox for keycard. And then also for keycard, I guess. That's the label. Well, I mean, there's two labels now. Yeah, because I do gems and red. Yeah, so it's just I should just remove this label. Okay, so now yeah, and then fuses left is just a span, I guess. And this should be a span ID with fuses left. Don't know what this GI class does exactly, but we can see that later. So now go back to the code here, and then we see fuses left. In the text, I should sanitize this. Keycard is a checkbox, and Vitalin is a value. So let's see if this gets loaded now. We don't need to recompile. Load an example key5 file. Okay, that's undefined. That's not good. Oh yeah, because we didn't. Yeah, of course. We are still loading key6 here as the hard-coded thing, right? So we need the module, we need the save game, and then the version. Load save game file, and then apply game state is depending on this. This can go even. And then instead of logging, we're going to do this for 6 and this for 5. Right, so now we're loading the correct game state for each version, right? So this shouldn't show undefined anymore. Yeah, 0 fuses left, no keycard, of course, and Vitalin is 0 because I just saved at the beginning of the game. So that's why it doesn't have any data, of course. Let's look at location for the white text. If I put something special there, location, span ID location. Oh no, so the GI might have to go here. No, okay, that's irrelevant. I can do that later. Oh, the span isn't closed either. That might help. No, it doesn't. But that's fine. So I should get a game that has some more data in it. So let's get us some Vitalin and and a keycard. I mean, I can just fake it, of course, because I don't know where the Vitalin is here. I think it's those green bottles, right? Yeah, these are green bottles. Yeah. So we have 5 now. Let's get a few more. 9. Okay, we have 12 Vitalin here, 13 Vitalin. Let's get the key card as well. And there's 0 fuses left. Let's put that on 1. And let's now save the game. Let's take the last one here. And now if we drop this last save game onto the thing here, yes, we have a key card, we have 1 fuse left, and we have 13 Vitalin. Yes. Yes. So that's indeed parsed correctly now. Completed levels need to be changed. Let's focus on the level. I want to see the level though. This happens in save game view. I don't see anything that is Keen 5 specific. We have our 3 planes, so let's look at the CPP file. This is all the same. So this, yeah, we need to change the shader because that one contains a hard-coded value of 2376, which is the amount of unmasked tiles. and also this one here, the tile atlas and the sprite atlas needs to be changed as well. These need to be predicated on the version as well, right? I'm requesting this from the app. Let's first load these textures. So if you look here, we have a glue-in for the Keen 6 tile atlas pick texture. I guess let's just load it, right? Yeah. Okay, so let's make these guys for Keen 5. The texture dimensions are probably just the files, the pixel sizes, right? Let's open this in a folder here, and let's double check the tile atlas for Keen 6. That is 1802 by 1010. Yeah, that's the size simply. So the Keen 5 sprite the Keen 5 tile atlas is 1802 by 902, 1802 by 902, and the sprite atlas dimensions for Keen 5 is 531 by 460, 531 by 460, and then the meta texture, we need one for 5 as well. And then we need Keen 5 sprite metadata row count 390. That is, what number was that again? That's from the pack sprites thing, right? I think I closed that window already. Crap. No, this is in the site thing. Keen helpers, pack sprites. Yeah, so the 346 is the thing here that we need. Sprite row count is 346 for Keen 5. And then the we have a setter for the metadata. Okay, we'll make one for 5 as well. And we have a getter for the sprite atlas metadata, which returns it straight here. And these are fine, right? So now we have to implement those. Also, we have to make some glue-ins or duplicate all of these for Keen 5. Okay, we need access to those. And now let's see what we can implement, right? Let's start with this one. This should have been in line, I guess, but fine. Actually, should we do this in line? Yeah, let's just do this in line because this is ridiculous. P5 Atlas texture. Six Sprite Atlas texture. That's this one. 5 Sprite Atlas texture is this one. And then the Sprite metadata texture. That's this one. And that's number 5. Okay. And then the setter, I guess that can also be in line. 6 sets metadata. This one. And that's it. Yeah, load static textures we need to do for our Keen 5 things as well. So we reserve or we initialize the textures here, but we fill them in from the JavaScript side. We just, because it's easier to do that here on the OpenGL side. Okay, so we have those initialized. This should all work. This is not dependent on which version we are in. Okay, so we have all the things right. I think so. Are we exporting any of these here? Yes, we do. In app, we have these guys. I think that's it. We have the vertex shader and the fragment shader, but that is not Keen 6 specific, so we can use the same shader for different versions, right? So we definitely don't need to name that Keen 6. Yeah, I did name those files Keen 6. Let's move that. I'm gonna git move that. To just Keen fragment shader and git move Keen 6 vertex shader to Keen vertex shader. Okay, and then we're going to remove, because they compile in this folder, so let's go into include Keen SE shaders, git remove these guys, because they are recreated every time I compile. If I make them dirty, I guess. Oh no. Why are we doing that? Did I accidentally? Open this file and oh yeah, I did edit it. Okay. Our shaders thing is empty, but this might be in a CMake lists thing. Yeah, it's complaining about the the fragment shaders. I think I'm including that somewhere. Where I'm including this? Yeah, these guys. Okay, these names have all changed, of course. And then I have to export it in main correctly. Oh, that was already that. Okay, sure. We were already in main. I meant these guys here. This needs to change. Shader program is Keen. This is gonna give some errors, of course, because I need to change it elsewhere too. Yeah, the shader blobs indeed. And then the shader program is used every time I'm rendering. I need to get the correct shader program. And what else do we have left here? There's still a Keen 6 here. Oh yeah, this is the location where we actually decompress or create a thing. That is good. And now we need to look at the JavaScript side because that's going to reference the Keen 6 thing as well. Yeah, so get shader blobs. Okay, this is just a decompression. That's fine. But no, I need the textures, right? The textures needed to be loaded. Yeah, load Atlas textures. Yeah, this guy here. So textures, this needs to be just, oh, no, this is correct. We need to do this for everything. Yeah, I'm gonna, this is duplicated code, which should be in a loop somehow, but I'm just gonna do it like, for now, I'm gonna just copy it. So this is where we actually load the files, the image files, and put them into the texture and transfer them to the C++ side and put them into the GPU. So I'm going to copy all of that and duplicate that for Keen 5. Okay, and then the source is Keen 5 tile atlas, and then the sprite atlas. And that goes from Keen 5 sprite atlas.png, and then the metadata is where they are located, right? The sizes of each sprite and the location of all the sprites within the atlas itself. I'm gonna check for Keen 6 here. Yeah, see, we did forget some. Multiple even. Oh no, this is 6 already. This is 5. Yeah, okay. So this is the first mention of Keen 6 in 6. Okay, so that is good. So now we are loading our atlases, both sprite and tile. Let's see if that fails. This could be cache problem. Load Keen. Oh yeah. Maybe I didn't export that function in this guy here. So do we have a 6 here? Oh yeah. That's a specific separate function we need for 5 as well. That's the binary file, right. We load this from the JavaScript side and we as binary data, and we transfer that or load that into the C++ side. So yeah, we have to have that function too. Main undefined symbol. MS Keen 5 sprite atlas metadata. Why is that not found? This is in the app. Should be a MS Keen. Oh, did I forget one here? MS Keen 5 sprite atlas metadata. It's right here. Oh, did I not? Oh, it's static, so I didn't instantiate it here. Yeah, that makes sense. All right, no errors. Okay, it looks different, but we're still loading the 6. Okay, we're still loading the 6 guy here. So did it look like that? I don't remember how that level looked. Was it a big tunnel? Not sure. I mean, the size might be, the level dimensions might also be incorrectly queried. Let's look. Let's see where we got now, right? Oh yeah, and I need to I have the hard-coded value too. Let's fix that first. Although, so in our fragment shader we used 276 here, this guy here needs to come in from the C++ side. That's an incorrect value, but we're still loading the tile atlas for 6, though we're not using 5, and that's in the same game view in our render function. Yeah, we need to determine here, this guy here. Yeah. So this is depending on which version we are in, right? Which is the current version. Do I have this in the app? No, this is in save game, right? I'm storing this in save game, which I can ask for. Yes, I can ask for. Okay. Do I ask for current save game here? No, I don't think so. Okay. Game version. Okay, now we can do stuff here. Yeah, because it's here. Here is where we load the correct texture into the, or we bind the correct texture, right? So I guess we have to switch. We're gonna have to do that like multiple times, and that does suck a bit. I mean, I guess I could move those. Yeah, I mean, I put them in order of like texture 1, 2, 3, 4, or 0, 1, 2, etc. But yeah, I'll just put those here. I mean, the numbers are gonna work, right? So we switch on current version. Okay, it's version Keen 5. I think I have to include something here. Version Keen 5. Actually, I can leave those alone. I just need, what does it return? A glue-in. Okay, no. I'm gonna move those back, and I'm gonna assign variables. That's much easier. 4, 5, 6, 7. And we just need the glue-ins of these 3 guys, right? Yeah, these are 3 glue-ins. Okay. We have sprite and metadata. Sprite metadata. Okay, so now we just set these correctly. Tile atlas texture, metadata texture, and sprite atlas texture. And now we do the same for, or we adjust for Keen 6 or Keen 5. 5, 5, 5. Okay, now we're loading the correct tile atlas and sprite atlas. This cannot happen. But fine. Yes, now at least we see the correct tile atlas being used. That's good. And 6 is still good. Okay. And now when we change the number here, the 2376 number, that should fix this being wrong. I hope. Maybe the level dimensions are wrong as well, because we have to see what we all, they're right here. These guys are two size these, and then these guys too. Okay, so let's just get these as well. Oh, damn, I can't. Okay, I can't. What is it called? The destructuring the thing straight into these variables, I think, or maybe I can. I'm not sure. I don't think I can if I define those things elsewhere, right? Atlas texture dimension. So I don't think I can do this. This doesn't work, right? Yeah, no, it doesn't do that. Okay, fine, like this then. And then these guys, also width and height. Okay, so we load these guys as well. And then for 5, we use the correct function here. Oh, that one was still wrong. I don't know. I've doubled that up. 5 and 5. Okay, so now we assign. We don't need these guys anymore because we've defined them before. Okay, and that's all the correct information, except for the one thing, right? The 2376 problem. But the level dimension should be better now. I mean, it is a bit bigger now. Now let's get rid of the 2376 to see if that fixes things. So in the shader here, we need to get this value in. So we need another float here. Unmasked tile count. And then we can get that here. Actually, this doesn't need to be. Yeah, I mean, let's just use it, I guess. So that means that we have to give that here as well. And that is a 1 float. And the value depends on the version. Which we enter here. And then we assign here. And that should be, I mean, should I hardcode it here? No, right? That should come from app, I guess. No, it shouldn't. I mean, for Keen 6, it's 2376. And for Keen 5, I already forgot. Do we still have this? I think we still have this number here. A mask task 1512. 1512. Let's try this one. And then we use a mask tile count here. Let's see if this works. Nope. This is wrong. Wait, I did decode the level correctly in my other thing here. Let's go look here to see whether the number is correct in game maps. I needed that number as well, right? Game maps. Wait, let's see. So if I do this, game maps render to PNG, I needed to know the start of the mask tiles as well. Key and level count. Yeah, these guys here. 237 and 1512. Was it 1512 that I used or no? Yes, I did. Crap. Why is that wrong? Does it work still in Keen 6? Yes, it does. Unless there's another hard-coded value in there that I missed. In the shader, I mean. No, 2376 only occurs once. Damn. And do we even have sprites? I guess if they're all unknown, it might skip them though. Oh no, we do. Yeah, we have our little guy here, yeah. So that does indeed work. But why is it so wrong? Let's look. So this was level 1, right? Let's look at this guy here. Yeah, so it's a okay. The level dimensions are definitely wrong because it's a vertical level, not a horizontal level, and this one is way too horizontal. So maybe it's just the level dimensions that are wrong, which would be weird because unless we did a typo and forgot to change out a value here. So tile atlas width, that's fine. I'm talking about level. Oh wait, no. This no. Of course. Where did I get the map size? Okay, level width. Oh, M level width. Okay, so this is wrong then. So level index, level dimensions. Okay, so based on, I'm asking the level index from the save game, which is fine. I'm asking its dimensions. Is this correct? No, it's definitely not. Okay, this is not indexed or predicated on the version, so that's fine. That's this wrong. That makes sense. Let's see if this improves things. That looks way better. That looks even correct. This is Keen opening his book, I think. I mean, there seem to be some sprites missing, though. If you look at also this one doesn't really look. Texture at unit 1 is incomplete. Dimensions of level base are not all positive. I might be loading the wrong thing here. So if you do the sprite bounding boxes, yeah, I think there is like an enemy at the top here, is there not? Or am I in a, yeah, the little electric guy here. These are not being placed yet. I don't know why they are absent, but at least we are rendering the level correctly. Also, these guys are wrong. These are barrels, I think, right? Are these not? Or like, oh, this, are the sprite indexes wrong? Because, yeah, there's flags here. Like the little guys are gone too. The sprite indexes are definitely wrong. There's something wrong with that. At least it's loading the correct texture for the sprites. But yeah, this little guy here, I don't think he exists in the game here either, does he? That might be that this bomb guy here. Yeah, so there's a problem with the IDs and the. Oh, do we have a? Yeah, I think there's a mapping between sprite ID or entity ID and texture, right? No, the texture is in the entity itself, right? So in the entity, we have the sprite ID plus 45. I wonder if it's the same plus 45. Very important to check, because that number might also be different. It probably is. Let's see, we have to go back to the debugger, which I closed. So if we go look at our symbols here, and we look at our entities, the key entity, yeah, so sprite plus 46. Let's, so he's reading the book now, right? So he was reading the book and it's 132. If we go look at 132 on disk here, no, I need to be in applications, games, DOS, keen 514. No, wrong. In Git, ROM hacking, build, and then DOS, keen, save game, and I look at the sprites. So the sprite ID is, he was reading a book and it's 132. And 132 is definitely going to be wrong because, so this is the gun, right? So, but this is plus 46. So if we subtract 46, so we have to do some calculations here. So 132 minus 46 is what it is in keen 6, which it would be in keen 6, which is 86, so sprite 86. Yeah, so that's the one we saw. This is not the reading a book. That's right. So the offset is wrong. So we just need to find now, Commander Keen was reading a book. We just need to find the correct sprite, and then we have the offset number. Yeah, it's this one here. I think this one is, what's he doing? And this is sprite 30. So we have 102, an offset of 102. That's correct, right? Yeah, 102. So let's change that first in the thing here. Here in ROM hacking, this one. This would be plus 102. So if we load this here now, this is plus 102. So that would be sprite 132 minus 102 is 30. I think it's this one, right? So yeah, he's just reading the thing. Okay, now where did I put that in the code on the save game editor? There's no plus or minus 46, I guess. Yeah, this one here, and this one here. Okay, these need to be predicated on the version as well. I think that was a number that could be deduced from somewhere, but I'm not sure. I'm just going to hard code it. That's fine. So let's put this in save game, and then let's make another static here. And we'll call that sprites index offset. And for key 6, this is 36, and 102 for key 5. And now we will change these values depending on which version it is. So, well, this one also checks the wrong Atlas metadata. Oh yeah, that's because it's the one at the bottom here. It's determining these guys here. Yeah, this is still a blue glut and a wrong sprite. So these need to be changed as well. Let's just switch on the current version. A vector of floats. How do we use this sprite metadata? Okay, we're just indexing. Okay. We'll have to dereference that, then that's fine. Okay. And we'll get the address of that. This should be const, I guess. Oh, yeah, okay. Enemies in level. Okay, let's do them one by one. So this should be working, right? Sprite metadata is the key 5. Sprite Atlas metadata. And then we use that like this, but that works, right? Because we're just indexing over the pointer, or do we have to do this? No, right? Because it's now a pointer, right? Instead of a, yeah, it's not a vector. You have to dereference the pointer first. And then we have to have a variable for our offset here, which is a size t. Sprite index offset. And then we're gonna get that from the app to, no, from the save game. Where are we? Oh, we're in the save game, so we can just ask for that. These guys here. Okay, and then we can do that. And then the possible enemies is also something that we have to change per version. For that, I need to know what the IDs are, or what which enemy corresponds to which ID, which I haven't done yet. But no big deal. So this is an ordered set. Just use a pointer as well here, though. and then we'll move this up here, and then assign it like this. So we have the pointer, and then there just needs to be a pointer, of course, and then that should be fine. Why can't you assign a const again? And then these guys, I don't know yet. Okay. So that's fine. That's to build a list at the bottom here to see which enemies are in the game we can place. But this was the important one, the sprite index offset, and we have another one here in the save game view. This is more important because this will determine the sprite being placed in the level in the thing here in the game. So we need to determine the offset. Do we have the I guess we don't have the thing stored here, so we have to fetch it every time. I mean, I guess it's fine. Does this pointer? Yep. And then switch on save game current version, game version. Save game version Team 5. And then we need to assign the offset here, right? So we have a size T sprite index offset, which we're going to assign. Oh, we can't ask for that, I think, because we don't have getters for that, which we have to then make, I guess, sprite index offset. So we have to do the switch we have to do the switch on this side. Let's add that here. That's just a const function, and we do the switch here then, right? Instead of here. Yeah, and then we subtract sprite index offset here, and now we just implement it over here. And then we simply return keen 5 sprite index offset. And for 6, we return the one from 6. And hopefully that would like place the correct sprites now. Why are we complaining? Okay, switch game version. I guess we can do that, right? Yes, we have the little guys up here. We have the little orb guy. We have our pushy guys. Keen is reading a book. Keen is reading a book. And that's it. Yes. Okay, so we're placing the correct sprites now. So these are barrels now. Okay, so the correct sprites get loaded. Yeah, that's about it. So what remains? So I don't have any enemies listed. For that, we need to determine what the IDs of the enemies are, of course. So we can easily do that by clicking on the enemy here. And this is entity 9 or entity ID 9, the little electric guy here. I just need to know the names. I don't know the names here. VOD. So what is that? Keen 5 enemies. Okay. What is his name? Sparky. Okay, that Sparky is 9. So we have a thing for that in save game here, I believe. Yeah, we still have to do that. And we have to do, yeah, okay. So yeah, this was 9. 9 is Sparky. So if I enter this name, then we will see the name here appear in the info pane here. I click on this Sparky. No, it doesn't. Maybe I didn't compile. Oh, yeah, no, that's maybe client side. Did I? That's weird. That should work. Yes, yes, now it says Sparky. I need to refresh. Let's see. I need to add those to the enemy list as well, right? So I have to do 2 things here. I need to close others, and I need to go to, where was that? The enemies. Was that save game view? No, was this save game? Yes, this guy here. So 9 is one. That's the Sparky. And now we go back to the game, or at least the thing here. What is this orb called? Sphereful. Okay, Sphereful is number 22. So we add 22 as an enemy, and we add it as its name. What else do we have? We have the little pushy guys. 14 for Little Ampton. 14. No, don't do that. And number 14. And then what else do we have? I think that's all in this save game. Let's do the next one. It would be good if I had this fixed as well, these levels, so I could take off a level. But for now, let's just go to the next level. I know there's multiple enemies there that we haven't encountered yet. I think there will be one, right, at least. Also, we're going to have to drop a file on that thing to see if that works. Okay, so we have the second one. Let's get that from disk. Yeah, okay, this one here. Let's see if dropping works. Yes, it does. This also loads the level seemingly correctly. I don't see any new enemies. Oh yeah, the thing here, the what's it called? The sparkle thing, Slice Star. Slice Star is 11. What else do we have? Yeah, I don't see any other enemies we haven't encountered yet. How do I go to the exits? The exit is top left, I assume. No, yes, top left to the through the two doors. I need. How do I get there? Oh, falling through here. Okay, so I go up and then around, open that one. Okay. I don't know these levels by heart anymore. I've only played those like in the 90s. Let's make sure we have all the keys here without, oops, not this guy. So I don't have to find those. But we do have to open the platform though. Don't crash. Okay, crash. Great. I was just trying to make it a bit bigger so you could see better. Yeah, I've seen it. It's going to crash again. If I make it too big, it's going to crash. I don't know why. Well, yeah, there's something wrong with the video. I can't make it too big apparently. And if I change it from or drag it from one monitor to the other one, it shows like a yellow rectangle. I don't know why that is either. And if I change the size of the window, then it resets. But yeah, fine. That's not a big deal. Let's exit this one. Of course, we have to set our God mode and jump cheat again. Nope, the next one. So let's give us the keys and let's go open that thing there. Oh no, I think I have to go down here. This one opens it up, right? I don't think I can get up here, can I? Maybe. Yes, through here. Put this one in. Oh yeah, that's for the key card, of course. Oh yeah, we have to drop down, I guess, through this one, for which I have to turn off the jump cheat. Oops. All right. Now we have more choice of levels. So I'll save here. And let's try one. Doesn't matter which one. This is a tunnel, right? Yeah, these are the horizontal ones, I guess. Let's see if we have a new enemy in this one. We have oh yeah, this guy here. I dragged him, that's why he fell. 16, and his name is 16 Volt Phase 16. And he is an enemy, of course. Okay. Also, do we list? No, we don't list the enemies at the bottom here yet, which is weird because that should work, I think. Well, we have to look at on the JavaScript side to see why that is. So these guys, all the same. Oh yeah, this big guy here. This is one sprite. Yeah, this is indeed one sprite. This is 12. Robo Red. Okay. I might go to the secret level and see if there are more enemies there. I think the little guy that walks around like the little robot guy, not a robot, but the little gnome guy or whatever is there. Yeah, this guy here. Let's see. Number 23. And what's his name? Goldblatt 23. Let's see what we don't have yet. So we have Goldblatt, Slice Star, Sparky. Oh, the Shellies. Yeah, we need the Shellies and the Shikari, of course. The Spindred we could have found in level 1, I think. Spearful we have, Full Face, Little Anton, the Spyro Grip we haven't seen yet, and the Shikari Mine. This is a weird image for a Shikari Mine. I don't know why they did that. Oh, and the Shockzone in the last level. Okay, so the Master, the Shockzones we can find in the last level, the Shikari Mine as well. This one we have to go back for. The Shikari will probably encounter 2 in the last level, and the Shelly 2, I think. So we just need to get through this one, which is quite easy, I guess. Oh, I think I have to play one more level before I can access the last level. Yeah, this one also has one that we need, though. This guy here. Where are we here? This guy here. 13. And this is called Spyro Grip. 13. And is there anything else in here? Oh yeah, these guys here. 18 for Spindred. 18 I said, right? Was it 18 I said? Yes. 18. And then yeah, I think the only ones we're missing are in the last level now. So let's look at the last level. How do I exit this one? We have to open this one, I guess. It's probably this one, maybe. Or that's just for the thing here. Maybe this, yeah, it's probably the one on the end here, right? So how do I get up through the pipe? No, that's just to open it. Yeah, just go over this one, I guess, and then let's try. All the way to the left, because this one is closed. Yep, this is closed, and then I think it's going to be the one on the far left here. No, crap. Is it this one? No, it's not. Damn. I don't know where the button is for this one. Where could it be? Is it this one? Oh yeah, it could be that one too, of course. The one in the center here. Oh yeah, it closed this one. Oh yeah, it closed this one, so we can go up here and then no, wait, I'm lost. No, there is a thing upstairs though. Up here, right. Oh, that opened that one. That was to get the green gem. I don't know where the other button is to open the thing here. Let's try again, see if it's open now. It's not. Oh, there's another button at the bottom left. Okay, sure, at the start. Right, here. For which you need the green gem, of course, so that makes sense. It's this one. Okay. Now it's open. And now we can see the final level, which contains the Shikari and stuff. That should be all the enemies. Okay. The doggy 21. And do we have regular Shikari here too? I think so, right? Where the gem is, right? These are regular Shikari 20. And I hope the master, oops, not here. The master Shikari is here too, right? He should be, yeah, this guy is 19. It was Master Shikari, right? Or what did I forget? Shikari Master, okay. So we have this one, the mine. Okay, the mine still. So Shikari Master. And then the mine. They are over here. 10. Wait, did I add the 19? Should be added here, and then 10 as well. And that is Shikari mine, yeah. And I believe that's it. Yeah, Shikari Master. Okay, let's look at the list here and look at the website. So we have Shikari Master, Shockzone, Shikari Mine, Spider Grip we have 13, Little Ampton we have, Bolt Face, yes, 16, Sphereful, yes. 22, Robo Red, Spin Red, Shikadi. Oh, Shelly, we didn't have, that's the only one we have. We don't have Shelly. So Goldblood, Sly Star, Sparky, yeah, Shelly. I don't know where Shelly is. Is it on this level too? Yeah, not sure. I guess I'll have to find that one later. All right, so if you want to try the thing yourself, you can go to the website and there's a blog post about the Commander Keen save game editor, which you can read, which contains most of what I'm doing today. But for Keen 6, as we're doing it now for Keen 5, at the bottom here is a link to the save game editor, and you can then drop a file, a Keen 6 file, of course, because we're still working on Keen 5, and then you can try and play with this yourself. You can move things around, you can add new enemies, you can do whatever you want with the save game, and then you can download the result here in whatever slot you want, and you can play the game yourself. So next time we will finish this, I guess, where we can write. We'll have to test writing out the file, downloading the file. We'll add Shelly to the enemy list, and then we'll see whether this list works, because now you can't place any items, any more enemies in the thing, because we're not populating the list of known enemies in the level. And then we'll change the completed levels to reflect the correct game, as well as hide the stuff that isn't applicable to Keen 5 here. And then we'll release, and we'll start on Keen 4 after that. So yeah, thanks for watching, and I hope to see you next time. Bye.